Good morning, everyone. Today we're going to be expanding on what you've been doing the last couple days. We're going to do a more advanced version of it, essentially. We're going to try to solve linear equations with rational number coefficients, especially ones that require us to use the distributive property, which is what allows us to multiply a number times numbers and variables inside of parentheses, but we're also going to do it with fractions today. So to do that, we're going to need a little bit of important vocabulary. You're going to see two things today. They're going to be written in green. Written in green means you do not have to include it in your notes. It's stuff that's useful in case you don't remember what it means, but we've done it enough that you probably already know what it is. So you don't have to include the stuff written in green in your notes. So our relevant vocabulary, our coefficient. This is the number in front of a variable. You could also think of it as the number multiplying the variable. We've got an example here, 2x equals 5. In that one, the coefficient is 2, because it's what's multiplying the x. Like terms. This is a sort of an oversimplified version, but it works for how we're going to use the term. Like terms are terms that have the same exponents and the same variables. So if we had this right here in front of us, if we were looking at 3x plus 5 plus 2x plus 1, well, we could say that 3x and 5x are like terms because they both involve a variable. And we could say 5 and 1 are like terms because they don't involve a variable. They're both just regular numbers. Now, if we were looking at this and we said 3x and 5, though, those are not like terms because one has a variable and the other one doesn't. Now, the distributive property. This is the math property that allows us to multiply the coefficient outside the parentheses times the numbers and variable inside the parentheses. For example, the distributive property is what allows us to say, well, 3 times the quantity of x plus 2 is the same as saying 3 times x plus 3 times 2, and that's the same as saying 3x plus 6. Alright, now here's a green one. This is one you don't have to write down, but it's still useful to hear. A least common multiple. That's multiples that are the same for two numbers are called least common multiples. Are called common multiples. For example, 8 is a common multiple of 2 and 8, but the smallest multiple that two or more numbers have in common is called the least common multiple. So the least common multiple of 2 and 4 is 4, because 2 times 2 is 4, and 4 times 1 is 4. Now for a least common denominator, on the other hand, that's just like a least common multiple, but it's for denominators. That's the bottom term of a fraction. So the least common denominator for 1/2 and 1/3 is 1/6. 1/12 could be a common denominator, but it's not the least common denominator. Now let's see a little bit of how we're going to use this in terms of our work today. For our first example, this is going to be an example of ones we've done before, so I'm going to write it in green, meaning you don't have to include it in your notes. Let's say we've got this equation in front of us. We've got 2x plus 1 equals 4x minus 5. We know how to do these. We've been doing these for a while. We think SADMEPS, subtraction, addition, multiplication, exponents, parentheses. And I've got to do the opposite of whatever's happening here. So for me personally, the first thing I want to do is get rid of that minus 5 by adding 5 to both sides. I'll get 2x plus 6. Those two 5's cancel each other, equals 4x. Now I'm going to subtract 2x from both sides to get variables on one side and regular numbers on the other, and I'll get 6 equals 2x Now, since that coefficient of 2 is multiplying the x, I'm going to divide by 2 to get x by its itty-bitty self now, and I'll get 3 equals x. So that's great for ones that don't involve fractions. Let's say I had one that did involve a fraction, which I'm going to write in black now. This means do start writing this down again. Do include this example in your notes. Let's say I've got 1/3 x plus 2 equals 1/2 x plus 1. Well, let's see. I'll just do the same thing as I did before. I'll subtract 1 from both sides to get 1/2 x by itself, and I'll get 1/3 x equal, 1/3 x plus 1 is equal to 1/2 x. And now to get both my variables on the same side, I'm going to go minus 1/3 x on both sides. And I'll get 1 equals, wait a second. What is 1/2 x minus 1/3 x? That's not super easy to know. But it is if you start out by creating a least common denominator or multiplying everything times a least common multiple. So let's cross this out and start that problem over again. I'm going to show you 2 ways that we could solve this. So starting over, we're going to call this one method 1. LCM. So if we have that same problem, and we say 1/3 of x plus 2 is equal to 1/2 x plus 1. This will be much easier if I put my fractal terms, meaning the ones that involve a fraction, in terms of their least common denominator. So sorry, that should say LCD. So I'm going to start by saying to myself, well, what's a fraction that both 1/3 and 1/2 could go into? Well, there are a couple ways you could find out. You could just ask yourself a couple of them. Let's see, can 1/3 be expressed in terms of fourths? No. Can it be fifths? No. Can it be sixths? Yes. Oh, and halves can be sixths too, because 1/2 is 3/6. Or you can use cross multiplication, where you go, alright, 1/3 equals, 1/3 times 2/2 and 1/2 times 3/3. 1/3 in terms of sixths is 2/6, and 1/2 in terms of sixths is 3/6. So now that I know that 1/3 in terms of sixths is 2/6, I can say 2/6x plus 2 is equal to 3/6x plus 1. Now let's see if I can do what I would usually do from this point. Alright, so I'll subtract 1 from both sides to get rid of this 1 that's being added. So now I've got 2/6x plus 1 equals 3/6x by itself. Now I'm going to subtract 2/6x from both sides to get the x's on one side and the regular numbers on the other. There we go. And this side cancels. Then I'll get 1 equals, sorry, it's being a little slow to show my work. 1 equals 1 over 6x. Because 3 minus 2 is 1, so 3 over 6 times x minus 2 over 6 times x is just 1 over x. So now, well, let's see. At this point, I've got two options. I can either do what I traditionally do, which is just divide by my coefficient, or I could multiply times something. I could just multiply times the denominator, which I personally think is a little bit easier. So I'm going to say times 6 on both sides. That's going to cancel. Good. And I'll get 6 times 1 is 6. And 6 times 1/6 is 1. So that's going to be 1x, which we can just say is x. Then I've got my final answer. I'm good. Now, option number 2 can potentially be shorter, but it has a little bit more chance of messing up in a small way. We're going to call this one Method 2. Multiply. So if again, this is the same original problem. Method number 2, and I'm going to put this one in green because it's the tiniest bit less useful for most people. In green means you don't have to write it down. Include it if you like it better, but otherwise leave it alone. So if I've got 1 over 3, x plus 2 equals 1 over 2, x plus 1. Well, if I know that the least common denominator for both 1/3 x and 1/2 x is 1/6, I can actually start out by multiplying everything times 6. So that means I'm going to say, all right, 6 times 1/3 x is going to be 2x. 6 times 2 is going to be 12. 6 times 1/2 is going to be 3x. And 6 times 1 is just going to be 6. And from this point on, I can treat it like a regular problem. I can just go, okay, minus 6, 2x plus 6 equals 3x, minus 2x, minus 2x, 6 equals x. Done. If you have any questions about this, you know that I'm right here in class for you. Have a good day.